What's up guys, it's Imran Fiaz and today's video is on atomic structure. Hoping to go through all the key points in atomic structure that you need to kind of know about. Atomic structure. So all about the atom. At the start of the 19th century, John Dalton described atoms as solid spheres and different spheres made up the different elements. 1897, J.J. Thomson discovered the electron, showing atoms weren't solid and indivisible. Therefore, the solid sphere had to be changed into a plum-pudding model. 1909, Ernest Rutherford and Hans Geiger and Ernest Marsden conducted a Goldfield experiment, found positive charge of particle at thin sheet of gold. Plum pudding suggested most of the particles would be slightly deflected by the positive pudding, which makes up most of the atom. But in reality, most particles pass straight through the gold, only a small deflected backwards. Therefore, the plum pudding model couldn't be right, because most pass straight through the gold. Therefore, Rutherford developed the nuclear model. The nuclear model is the idea of a tightly positively charged nucleus surrounded by a cloud of negatively charged electrons. Most of the atom is empty space. Scientists then realized electrons on a cloud around nucleus, as Rutherford described, spiral down into nucleus. Therefore, the atom collapses. What did Niels Bohr propose? A new model where electrons exist in shells, orbits of fixed energy, and when electrons move between shells, electromagnetic radiation, fixed energy, emitted/absorbed. Scientists later discovered not all electrons in a shell have the same energy. Therefore, they even refined Bohr's model to include subshells. Relative atomic mass, AR, average mass of an atom of an element on a scale, an atom of carbon-12 is 12. Relative isotopic mass, mass of an atom of an isotope of an element on a scale, an atom of carbon-12 is 12. Relative molecular mass, MR, average mass of a molecule on a scale, an atom of carbon-12 is 12. Through definitions you should memorize. 4 things that happen when a sample is injected or squirted into a time-of-flight mass spectrometer. Ionization, I'll go through the 2 types later on. Acceleration, positive charge ions are accelerated by electric field, so they all have the same kinetic energy. Acceleration, positive charge ions are accelerated by electric field, so they all have the same kinetic energy. Ion drift, ions enter a region with no electric field, so they drift through it. Detection, ions that have a lower mass to charge ratio travel at higher speeds in drift region. Detector detects charged particles and mass spectrum produced. Detectors using mass spectrometers detects charged particles. Electrical current produced in detector when charged particles hits it. 2 types of ionization. Electrospray ionization, sample is dissolved and pushed through a small nozzle at high pressure. High voltage applied to it, causing each particle to gain a H+ sign. Sample is turned to a gas made of positive ions. Or electron impact ionization, sample is vaporized and electron gun used to fire high energy electrons, knocks 1 electron off each particle, gains becomes 1+ ions. Mass spectrum. Mass spectrum is mass/charge plotted against abundance. Y-axis gives abundance of ions for an element. High of each peak gives a relative isotopic abundance. If the sample is an element, each line represents a different isotope of the element. X-axis given as a mass-to-charge ratio. State a key fact about elements with different isotopes. Producing more than one line in mass spectrum because isotopes have different masses. How molecular ion M+ is formed in mass spectrometer when 1 electron is removed from the molecule, giving a peak in spectrum with the mass-to-charge ratio equal to the MR of the molecule. Each shell is called a principal quantum number. The further a shell is from the nucleus, the higher the energy. That's really important. The further shell is from the nucleus, higher the energy and larger the principal quantum number. Subshells have different number of orbitals, each hold 2 electrons. 2 electrons are in each orbital spin in opposite directions. 4s subshell has a lower energy level than 3d subshell, even though principal quantum number is bigger. So 4s subshell lower energy level than 3d subshell. Therefore 4s subshell falls first. Chromium and copper, you need to know about these 2 exceptions. They donate 1 of the 4s electrons with 3d subshell to as happier with a more stable full/half of half-full d subshell. So chromium 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Copper, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Transition metals, when they become ions, they lose the 4s electrons before the 3d electrons. Number of outer shell electrons decides the chemical properties of the element. D block elements lose the s and d electrons, forming positive ions. D block elements lose the s and d electrons, forming positive ions. First, ionization energy needed to remove 1 electron from each atom in 1 mole of gaseous atoms from 1 mole of gaseous 1+ ions. Now, just these kind of definitions, right? They're very imperative to learn because they give you so much more deep understanding, right, of what it is. With one electron, it has to be in the gaseous atom to form 1 mole of gaseous 1 plus ions. And just by memorizing definition, you know all of that, right? You have to put energy in to ionize the atom, therefore it's always going to be endothermic. Lower the ionization energy, easier to form an ion. Shielding, lessening of the pull of nucleus by inner shells of electrons. 3 factors affecting ionization energy: nuclear charge, more proton nucleus, more positive charged nucleus, stronger attraction for electrons. Distance from nucleus: an electron close to nucleus is more strongly attracted than one further away from nucleus. Shielding: as the number of electrons between outer electrons and nucleus increases, outer electrons feel less attraction towards the nuclear charge. High ionization energy, high attraction between electron and nucleus, therefore more energy to remove the electron. Second ionization energy needed to remove 1 electron from each ion in 1 mole of gaseous 1 plus ions to form 1 mole of gaseous 2 plus ions. Why does within each shell successive ionization energies increase? Electrons being removed from increasingly positive ion, therefore less repulsion amongst the remaining electrons held more strongly by nucleus. Say what a big jumps in ionization energy happen when new shell broken into, electron move from a shell close to the nucleus. Successive elements down the group have extra bigger shells. Why does the ionization energy decrease down group 2? Each element down group 2 has an extra electron shell compared to one above. Extra inner shell shield the outer electron from attracting nucleus. Extra shell, therefore outer electron further away from nucleus, so attraction reduced on nucleus.